Today we'll be moving on to proofs involving parallelograms. The do now, I hope you filled it in already or tried. In a parallelogram, opposite sides are parallel and congruent. Doesn't matter the order which one you write first. In a rectangle, diagonals are congruent. So these were all properties of the different quadrilaterals that we discussed back earlier this year. You should have flip card notes on them as well. So I cut out just the two sections that we'll be looking at today from what I put in yesterday's notes. To prove that a quadrilateral is a parallelogram, there are 4 different methods. We could, for the first bullet, use the distance formula to show that both pairs of opposite sides are congruent. So that would require you to use the distance formula or Pythagorean theorem 4 times to show the length of all 4 sides, and then you'd be able to state that the opposite sides are congruent. The method that I always choose to use only requires you to get 2 things. If you find the midpoint, use the midpoint formula to show that the diagonals bisect each other, you would only have to get the midpoint for each of the diagonals, and that's only 2. So that is the quickest way of doing it. The next option is using slopes to show that both pairs of opposite sides are parallel. So if you get the slopes of all 4 sides, you could show that the opposite sides have the same slope, so they're parallel. The last option, you could use slope to show that one pair of opposite sides are parallel, and then also find those lengths, either using distance formula or a Pythagorean theorem, to show that those same sides are also congruent. So showing that one pair of opposite sides are both parallel and congruent. So I'm just going to focus on the starred one. Then, to prove that a parallelogram is a rectangle, so notice this is saying to prove that a parallelogram is a rectangle. So you always have to be careful how to state the question. If they just tell you that it's a quadrilateral, usually you first have to show that it's a parallelogram. And after you know that it's a parallelogram, you could show that it's a rectangle. You know, it's funny because I started the first one because that's the way I used to always do it, but I might choose the second way today, in which case that means the star will mean nothing. So once you have that it's a parallelogram, which I would do using the midpoint formula 2 times, then you could show that it's a parallelogram whose diagonals are congruent. That would require to use the distance formula or Pythagorean theorem twice to get the length of each of the diagonals. And then you could say that they're the same. Or get the slopes to show that 2 consecutive sides of the parallelogram are perpendicular. And if they're perpendicular, that means you would have a parallelogram with a right angle, and then that's a rectangle. I will complete, I think 2, and then I'm leaving 1 for you. Yesterday's, a lot of you did not do a perfect proof for the last one, even though it was exactly the same as the one before it. So please go back. It's in the Google Drive and check out what you should have done. I'm going to plot. I forgot to plot these before starting the video like I did yesterday. I apologize. But this will give you time to plot them as well. Here are my 4 vertices. So I'm first going to graph the parallelogram, try to be a little neater. I hope you too. Okay, so we're trying to prove that this quadrilateral is a parallelogram. So a parallelogram, now you could determine which property of a parallelogram you're going to use. There are 5 of them, I believe. Were there 5 things here? No, 4, sorry. We could either state that the pairs of opposite sides are congruent. We could state that the diagonals bisect each other. We could state that opposite sides are parallel. Or we could state that one pair of opposite sides are parallel and these same sides are congruent. So you state the property that you're going to use in your proof. So for me, and probably you too, I'm going to use that one. So a parallelogram is a quadrilateral whose diagonals bisect each other. If you're going to use one of the other methods, okay, it'd be easy enough to Google it if you wanted to, and then you would use that property. Formulas, if I'm using to show that the diagonals bisect each other, I'm going to use the midpoint formula. Okay, add the x coordinates, divide by 2. Add the y coordinates, divide by 2. And I'm going to write 2 times. Okay, so we only need to use one formula here. So my work is going to be to get the midpoint. Let's first get the midpoint of MT. Midpoint equals. Okay, so looking at the coordinates for M and T, let's first look at the x coordinates, -4 and 4. So -4 plus 4 divided by 2. Then I'm going to look at the y coordinates, -2 and 2. -2 plus 2 divided by 2. All right, both numerators give me 0. So 0 divided by 2 and 0 divided by 2, I get that the midpoint is 0, 0. Now let's get the midpoint of the other diagonal, AH. Midpoint equals. The x coordinates of A and H are -2 and 2. Divided by 2. The y coordinates are 2 and -2. Divided by 2. So again, we get zeros in the numerators. Divided by 2, I get 0, 0. So notice they have the same midpoint. Diagonals have the same midpoint. That's what we just showed. Now we could say MATH is a parallelogram because diagonals bisect each other. So you need to understand that because the diagonals have the same midpoint, that is enough to show that the diagonals bisect each other. And that makes the quadrilateral a parallelogram. So if I had drawn this perfectly, you'd see that they intersected each other at 0, 0. Making this segment the same as that, and this segment the same as that. Okay. Number 2, we are not only proving that it's a parallelogram, now we want to prove that the quadrilateral is a rectangle. So a rectangle is a parallelogram with, so we need to decide, are we going to say that it's a parallelogram with congruent diagonals, in which case we'd get the length of each of the diagonals and show that they're congruent, or are we going to show with a right angle? I think I'm going to do that one. Parallelogram with a right angle. So again, I'm not doing the one I starred, I'm doing the other one. So I forgot to 6, 3, 5, 5, and 1, 3. I'm just going to move that P outside of the rectangle. I'm going to erase it. 2, 1. So if I want to show that the quadrilateral is a rectangle, I first need to use the midpoint formula again to get that it's a parallelogram. Okay, so in yesterday's, that last proof, you needed to use two different formulas, yet most of you just used one. I don't know why when the one right before it. So today again, the last proof that I'm leaving for you is just like the one right before it, proving that a quadrilateral is a rectangle. So we're going to use the midpoint formula 2 times. I could write that right here. And then if I'm going to show that it has a right angle, I'm going to find slope. So instead of using slope formula, since we're graphing it, I'm going to use rise over run. And that's going to be 2 times as well. So let's first start with the midpoint of PU, one of the PU, one of the diagonals. The midpoint equals P has an x of 2, U has an exponent of 5, so 2 plus 5 over 2. The y's are 1 and 5 divided by 2. So the midpoint is, this is 7 and 6. So we have 7 over 2, I'll just leave it a fraction, 6 divided by 2 is 3. And then after PU, SL or LS, doesn't matter. Midpoint equals the x coordinates 6 and 1, so 6 plus 1 divided by 2. The y coordinates 3 and 3, 3 plus 3 divided by 2, and you get a 7 and a 6 as the numerator. Then divide them by 2 again, so it's 7 over 2 and 3. So here I could see diagonals have same midpoint. So that was the first half of my work. The second half of my work, if I was doing the other method that I starred, I would get the length of those two diagonals. So you could either use right triangles and use Pythagorean theorem, or you could use a distance formula. I'm going to get the slope of two consecutive sides. So I'm going to do PS and PL. I don't like my thick lines. They're going to make it actually harder to do, but I'm going to show that this is a right angle right here. So for PS, slope equals, from S, I'm going to go to P, down 1, 2, so it has a rise of negative 2, right 1. So the slope is negative 2 over 1, or just negative 2. Then to go from P to L, slope equals, let's change my color. From here to here, I'd go up 1, 2, and to the right 1, 2, 3, 4. Up 2, right 4, so that's 1 over 2 if I simplify it. A lot of you yesterday didn't even get opposite reciprocal slopes, but so that there was a right angle. Okay, you have to have the opposite signs. So here, one of them's negative, and one of them's positive. One of them is 2 over 1, one of them is 1 over 2. So opposite reciprocal slopes So we know that PS is perpendicular to PL. So that's a big concept, understanding that if the two lines have that opposite reciprocal slopes, you know that they form a right angle. So now, after showing that they are both have diagonals that bisect each other because they have the same midpoint, and two consecutive sides that are next to each other that have opposite reciprocal slopes, so they're perpendicular. Now I'm ready to conclude that PLUS is a rectangle because diagonals bisect each other and there is, sorry, and it has a right angle. So again, there are several different ways to do this. I'm showing you one way. You could stick with that way or feel free to look up how to use one of the other methods that I stated here. There are 4 total methods to show that a quadrilateral is a parallelogram, and then 2 other methods to show that it more specifically it is a rectangle. Finish the last one before turning it in. Thank you.